Good afternoon, everyone. We will continue our discussion on pointers today and we'll try to finish the discussion on pointers. In the last class, what we were discussing was the relation between pointers and array. And in that I told when you create an array, internally this name of the array x here in this example, internally compiler treats it as a pointer. Okay. And if you simply refer to x, that means it refer here when I'm creating this x of 5, int x of 5, an array is created with the 5 elements. Okay, maybe I'll create it to 3 elements because only 3 elements are here. Okay, so when I declare this is created and the starting address of the array is 1000. Starting address means start address of the first element. Now internally what compiler does is a pointer is created and the starting address of this array will be stored here. Okay, because of that, since it is internally a pointer and that name of the array contains the address of the starting of the array, we can declare another pointer and assign that address. So x contains the address of the array, address of this location, first element in the array. I can create a new pointer and assign this value of x to that pointer. Now px is having the address 1000. Here x is having the address 1000, address of this location. Now px is having. After that you can use px as if it is an array. So if you put px 0, it refers to the first value, first element stored in the array. If you refer to px1, it refers to this. So now it's like wherever you use x of 0 or x of I, you can use px of 0, px of 1 or px of I. That is a relation between array and a pointer. Okay, so that is what we were discussing in the last class. Today we will discuss some more topic with respect to pointers. There is a classic example. I taught you call by reference using pointers. Call by reference using pointers. There what we did was we created a variable and we have a function called modify, and we want to modify the variable value within a user defined function. So what we did is variable is here in the main and we passed address of it. To the modify function we passed the address of it, and that address is stored. This is the actual parameter. The formal, since address we are passing here, the formal parameter is a pointer, because address we use pointer variables to store addresses. So since we are passing address in formal parameter pointer p, we are storing it. Effectively what happens is this pointer p belongs to this function, but it is pointing to x. When x is here in main, variable x is here main, having the value initially 10, and within the, so when we are passing it, this pointer p is now pointing to x. So here within the function I am changing that value by dereferencing the pointer. So star p equal to 100. When I do, I get this. Okay, this was call by reference using pointer. You are passing the address of the variable, and the change made in the user defined function is reflecting back to the main function. So after this, if I print, value 100 will be printed. Here value 10 will be printed. Here value 100 will be printed because x value is now 100. Now in the similar line we have a classic example for call by reference, that is called exchanging the variable values. Exchanging the variable values, exchanging the values of two variables within the main function. Okay, here I have a main function and another user defined function called swap. The purpose of the swap function is to exchange the values of the variables defined in or declared in another function. Now here the other function is main function. So I have two variables int a and b, and I am, before calling that function swap, I am printing the values. So this will be printing 10 and 20. A is equal to 10, b is equal to 20. After the call, what we want is, when a same message is printed, a is equal to percentage d, b is equal to percentage b, percentage d, a comma b. Same statement I am issuing here. One is before the call to swap function, another is after the call to swap function. So after calling the swap function, when I print it again, it should print 20 comma 10. Here when I am printing, it will print 10 comma 20. Here it should print 20 comma 10. That means a should contain the value 20 and b should contain the value 10. That means exchange the original value. A is having 10 and b is having 20. We want to exchange these values. A should contain 20 and b should contain 10. And this function should do that. Okay, that is what this example. This is a very popular example and very commonly asked in exams. This question. Exchange variables using call by reference to a user defined function. Now what we are doing here, we are actually passing the address of a and b, similar to what we did in the case of modify function. Here to modify, only one parameter is there. Here we have two parameters. I'll take you to the program here so it's better visible. So I'll execute this once first, then so you can see here these statements. Before call, a is equal to 10, b is equal to 20. I am not making any modification within main function. After the call, a is equal to 20, b is equal to 10. So the values of the variables are exchanged. So in between these two print messages, I am calling only this function, user defined function, and I am passing the address of a and address of b. Now since it is address of a, in the formal parameter I have a pointer. So PA will be pointing to a. PA, which is a pointer variable in swap function, is pointing to a, and PB will be pointing to variable b. The picture is here. PA, pointer PA, has the address of this variable a. I have not mentioned the address value, so some value is there. Now PA is pointing to a, PB is pointing to b. Now within the function, what we are doing is int temp is equal to star PA. Since PA is pointing to a, star PA means 10. We are dereferencing and get the value in a. So effectively what happens? Temp, it is as good as putting temp is equal to 10. PA points to this one. So star PA gets me the value stored in the variable a. Value stored in the variable a. So effectively temp is assigned with the value 10. After that means star PA is 10. Okay. After that, star PA equal to star PB. PB is pointing to variable b. Star PB gets me 20. And that 20 I am assigning to star PA. When I do star PA, that refers to this variable, destination of pointer. PA means pointer variable. It has an address. When I do star PA, that means dereferencing, I get access to this location, and there I am putting the value stored in variable B. So effectively what happens is star PA is assigned with 20. That is, A is assigned with 20. Star PA actually refers to variable A. After that, in the last statement, what we do is star PB equal to temp. Temp is what? Temp is assigned with 10 already. That value of temp is assigned to star PB. So PB is a pointer pointing to variable B. Star PB means we are referring to the memory of B, and to that 10 is assigned. Okay. So in this function, this is what is happening. We temporarily store the value in the destination of this pointer, which is 10, in a temporary variable. Then value in B referred by star PB, that is stored into A referred by star PA, and in PB we are putting the value we temporarily stored here, that is 10. So after this, if we this is after doing that, this is the scenario. Initially PA is pointing to variable A and 10 is there, and PB is pointing to pointer B, variable B, and 20 is there. After performing this operation, we get 20 here and 10 here. So that this thing, exchanging this value, is done using the pointer variables PA and PB. Now this function returns this function swap. We made a function to swap function, and after execution it will return to here. There it will print A and B. Now this is the scenario. When A is printed, 20 will come. B is printed, 10 will come. Initially when we printed, we did not call swap. Before that we did the printed the values of A and B. So that time 10 and 20 are printed. Now 20 and 10 will be printed because we exchanged the values of A and B. Is this clear? So any variable value, any values we put into this two integer variables, that will be exchanged by calling this function. This is the output. So this is a very classic example, very commonly asked in exams and all, and it will help you to understand better what is called by reference. If any doubt is there, you can ask me. Okay, hopefully there is no doubt. The next last topic which is an SLE. Will increment factor for pointers. Pointers means pointer variable. I'm creating three variables. Let's three or four different variables, I can say. Say char B. I'll put some value there. Then a floating point variable, float C. I'll put some value 1.34. Then I'll create a double D equal to some value. Okay, value is, this is followed by, I'm going to create four pointer variables. So in the star PA, A is an integer, so I'm creating an integer pointer and storing the address of, or I can declare, then I can do PA equal to ampersand A. So address of A is assigned to pointer PA, and I can come instead of doing it in initial assignment in two steps, declaration and assignment in two steps, I can do this way also. So in case of char, I will create char PB equal to ampersand b. So these are two ways of creating a pointer variable and initializing it. One is you declare first, then assign the address. Otherwise, do those two steps in one line. Okay. So address of b is assigned to pb. Then float star pc equal to ampersand c. Floating point variable c is there. I'm making pc to point to this, and for that I have to create floating type pointer. Then last one pd equal to ampersand d. Okay. So now I'm going to print the value stored in PA. Or value stored in PA is address of variable A. So PA equal to percentage D. Anyway, address is a number. We can print it as a number. So I'm printing with percentage D, so that it will come in decimal. If I put percentage X, it will come in hexadecimal. PA. If I put star PA, I will get the value 10. But if I put simply PA, I will get the address of A, because we stored the address of A in pointer PA. So I get some value 6422012. I'm going to increment this PA plus 1. I'm going to increment it by 1. Okay. So now I'm going to execute it. PA is ending with 2012. When I did plus 1, it is printing 2016. Normally when we do plus 1, we expect 1 2. If it is ending with 1 2, we expect it to become 1 3. But it is not happening. Okay. So that is a behavior of the pointer. Since this is a pointer variable, when we increment by 1, it is not the absolute value stored in this is going to get increased by 1. When we do when PA is a pointer variable and it has some value, when you increment, it increments by the size of this variable, size of the destination variable type. PA is, so we got some 12 at the end, and PA is an integer variable. We know size of integer is 4 bytes. So when you do PA plus 1, the increment happens actually is by 4. So 12 becomes 16. So 6422012, 6422016. So that is a behavior of the pointer variable. The reason is that since it is a pointer variable, it points to the integer. The compiler knows that integer takes 4 bytes. When we do PA plus 1, the compiler thinks that we want to point to the next integer. Since integer is 4 bytes, next integer will be after 4 bytes. Size of integer is 4 bytes. Next integer will be after 4 bytes only. It will come if this integer starts at 12, address is at 12. If at all there is another integer, its starting address will be 16, because byte 12, 13, 14 and 15 will be occupied by integer A only. So integer A requires 4 bytes. Because of that, 12, 13, 14 and 15 will be occupied by integer A only. The next location free, or if at all there is another integer, that is going to be at 16 only. In that consideration, when you increment a pointer variable which is pointing to an integer type variable, it will increase by 4. That is size of the destination data type. Destination data type is integer, size of integer is 4 in my machine. Now what happens to other data types now? So I'll add print the value address stored in PB, that is a character pointer. PB is a character pointer pointing to a character, and I will print PB plus 1. What do you expect? If PB is ending with say 12, PB plus 1 will be what? Can anyone tell? Based on what I explained here. Suppose PB is ending with 12, PB plus 1 will be PB, value of PB plus size of the destination data type. Size of the destination data type is character. Size of the destination data type is 1 byte. Character is, in most of the systems, character is 1 byte. So when I do this, PB is equal to ending with 2011. Okay. And PB plus 1 is 2012. So increased by size of the destination. When a character pointer value is variable is incremented by 1, the size of the data type character data type is 1. Because of that, the increment factor is 1 here. Here integer pointer increment factor is 4. 12 plus 4 16. Here character data type increment factor is 1. Similarly, if we check for the other two data types also, you will find by what factor the pointer value is increasing. So we will make it PC. PC is a floating point type pointer. PC plus 1. PC is 2004. The address ends with 2004, and PC plus 1 is 2008. That means for floating point variable also increment factor is 4, because size of a floating point variable is 4. And last one, double pointer PD plus 1. PD address value is 92, ending with 92. PD plus 1 is 1000, or it is 1992. PD is address value is 1992, and it is incremented by 8, because the destination data type is a double variable, or the pointer type is double, and the size of double is 8. So increment factor is 8. So PD plus 1 results in the absolute value incrementing by 8 from 1992 to 2000. Is this clear? So increment factor for a double is double pointer is 8. Because the size of double variable in my system is 8. Increment factor for a floating point variable is 4, because floating data type size is 4. Here character is in most of the system it is 1, integer 4. Okay, is it clear, or any doubt is there? Now what if I increment by 2, PD plus 2? We'll see. PD is 1992, PD plus 1 is 2000, that is increased by 8. PD plus 2 is 2008. So it goes on like that. So PD plus 1 is value stored in PD, that is to 1992 ending the address that is ending with 1992 plus 2 into size of double. The absolute value stored in or integer value stored in PD, we treat it as an integer, and the integer value stored in PD into 2 into size of double when I am incrementing by 2. So it was, how was it? It was 1992. The address was ending with 1992 plus 2 into 8 equal to 2008. That is what you are seeing here. Other part is common, 642, that is not changing. 1992 plus 2 is 2008. Or in general I can say write increment factor of increment factor of double type pointer. Okay, so now if I do PD plus n, say where n is some value, so here also it will become n. Since the pointer is of double type, I am saying that size of increment factor of double type pointer. Generally, if it is integer type pointer, value will be increment factor of int type pointer here in this case. Okay, any question? Increment factor. So increment factor for a different pointer types are having different increment factors, and it is the size of the data type that pointer is pointing to. For an integer it is 4. So this is an SLE topic in fact, and in the exams you get SLE questions similar in this fashion. Okay, so with that I am done with pointer topic. If you want you can take a snapshot of this. Okay, this one we will make our assignment question. Next assignment question, this one. You can take a snap. So this is very commonly asked question in exams. So 28. Swapping variables using call by reference. Okay, so any question, doubts regarding pointers topic? Okay, if not we will take up the next topic, that is file management in C, and this is the last topic of your syllabus, as well as fifth unit. So in file management, what we do is, using the C program, we'll create file, write some data into a file, read from the file, etc. So far we were dealing with data that is present in the computer memory, primary memory. Okay, now there is another memory called secondary memory, right? Your hard disk or your flash memory in your mobile, 32 GB or 64 GB or 128 GB. They are secondary storages. Secondary storage means you store data normally in the form of files, and if you switch off the computer or your mobile, your data will not go anywhere. Once you restart switch on, it will be there. But so far what we are dealing with was in memory data. In memory, that means we store data in the primary memory. Whatever variable created, it is in the primary memory. Whatever array we created, it is in the primary memory. It was not stored in the secondary storage like hard disk or flash memory. Now, when the amount of data is very huge, it will not be possible to store all the data within the computer's primary memory. In that case, what we have to do is we will have to store it in a secondary storage device like hard disk. Okay, so that is the major purpose. Now normally when you download a movie into your computer or into your mobile, that will be in the secondary storage. But when you are watching it, temporarily those video content or movie content will be copied into the RAM, and then it will be passed to the your display. The movie player or video player will be displaying it on the screen. Okay, but the complete movie content, if it is a high definition movie, it will be of 4 GB or so, sometimes 2 GB or 4 HD or 4K movies will be very huge. All those data cannot be stored in the primary memory. Normally primary memory will be 2 GB, 4 GB, etc. And there are many other things we want to store in the primary memory, not just a movie, the application, the operating system, all those things are required in the primary memory. So the purpose of files is to store data permanently, so that when you power off the computer system, the data is not going anywhere. When you power on, you can get that back by reading the file from the secondary storage. Okay, that is what file management. In C we can create files, we can store some data. We will see simple examples. We will use not a movie. We will not create a movie file. Rather, we will create a text file. Okay, because we are not writing a video recording application. But when you are when you launch your say video recording application in your mobile, what it does is the data input device is your camera and as well as your mic. So video data will be captured by the camera, audio data, speech data will be captured by the mic. Then both of them are put together and written into the disk as a file, with normally with an extension of .mp4 or not .mkv or .avi. There are different formats for storing the data. But we will deal with only text files here, not so advanced. C programming language does not support that much of advanced things, or we are not going into that much advanced level. Now the common operations with the files are like open or create a file. If there is a file, we open it, otherwise we create a file and open it. Okay, now read data from the file. If there is any data existing in the file, we can read it. Then we can write that data into the file. Then opposite to open, there is a function called close operation or function. So these are the common operations we will study with respect to the files. Opening or creating a file, reading content in the file if at all there is any content, otherwise write some content into the file and then close the file, etc. And for all these operations there are functions available. So essentially it boils down to learning some functions. We studied many functions: printf, scanf, string compare, strcmp, string copy, strcpy, many library functions. And here also we need to learn a few set of library functions. First one is for opening or create a file, fopen. Opening as well as creating, we are using the same function, fopen. F indicates file. So it's an operation with related to file. That is why the function names are starting with f. F open, f close. Then so here there is an opening operation. Correspondingly, there you have the closing operation of the file. You can, it is analogous to you are clicking on a file and say I'm opening a file and I'm closing a file. So this you are doing with the help of graphical user interface. But programmatically also we can open a file and close a file. Then to read a character from a file, there is a function called getC. Somehow they have not used f here, that convention, but we can use to this function to read a character from the file. To write a character into a file, we can use putC. Then similar to printf and scanf, we have two file related functions also. fscanf is used to read the content from the file. So if getC is a very specific function, you can read only character. fscanf is a very generic function. We can use any data type. So fprintf is the opposite of that. We can write data into the file using fprintf. And there is another pair of functions, getW and putW. This is for character, whereas this getW is for reading integer from the file, integer data. So integer data, and write integer data into the file, we can use putW. Okay, so these are the set of functions you need to learn. Simple only. Yeah, maybe few are little new for you. Maybe fopen may be little new for you, but fprintf and fscanf is very similar to your printf and scanf. Just one extra parameter into this. Okay, so we'll learn what those parameters are, etc. So first you will go to fopen function. Fopen function. Before that, there is a data type called file. There is a data type called file. Basically, it is a structure, and it is we are not creating the structure. You know, structure is a user-defined data type. So it is somewhere created already, and it is available in a header file. Maybe it is coming to your program through stdio.h. So structure is a user defined data type. Once you have a user defined data type, we can create a pointer of that type. Okay, so file all capital is a user defined data type of structure type, and it is already defined by somebody and it is given to us. So when I say built-in data type, I mean integer, character, double, float, etc. But file is not such a data type. They are part of the language, but this is part of the library files, header files, and it is a structure type. So that's why we can consider it as a user-defined data type. This data type is required for all operations with file in C. So what we need to do is create a pointer of that data type. Okay, once you create a pointer, when we want to open or create a file, we call fopen, and whatever is returned by fopen will be stored into that. So since this is a pointer, it is obvious that whatever is returned by this will be an address, because pointers are used for storing address. So what happens is this fopen will create internally, fopen will create a structure variable. File type structures variable will be created, and its address. When we create a variable, memory is allocated and its address will be returned by fopen, and that address will be stored here. Okay. Now fopen, what are the arguments to fopen? First one is the name of the file we want to open or create, and the mode of opening. Mode of opening means whether we want to open that file for reading or writing or both or appending. So different modes are there. Examples are read mode. That means you want to open a file for reading only. Write mode. You want to open a file only for writing, no reading. Then we can open it in such a way that we can read as well as write. Or we can open a file such a way that we can add data at the end of the file. Appending or attaching data at the end of the existing content in the file. So these are the possible values for mode. In which mode we want to open the file so that the corresponding operations can be performed. File name is the name of the file we want to open. So here are the examples. So fopen takes two parameters. One is the file name which that we want to open or create. I told if the file is not existing, it will create one. Okay, so fopen can be used for opening a file or creating a new file. So example for mode is R plus. Okay, so and here I am open again. I am calling fopen and result.txt is the file name which I want to open, and here I am specifying W. W stands for write mode, R stands for read mode, R plus stands for read and write. Similarly, W plus also stands for read and write. These different values, both the parameters are strings because it is indicated by the value I am passing. Actually, it is enclosed in double quotes. So whatever we enclose within double quotes in C, it is considered as a string. So this is a string, and the mode is also a string, either made of one character or two characters, R and plus. Okay. Now, suppose I am trying to open a file and that file is not there, and the mode I am applying is R. Okay. If the file is not there, it will return something called null. Null is actually referring to 0, or 0 is given with a name given for 0. So normally if some integer value variable is having value 0, we say 0 is there. But whenever a pointer variable is having value 0, we call it as a null pointer, or null value is assigned. Just a differentiation. So it essentially refers to 0 or nothing, no value. So if I am trying to open a file, and if it is in read mode, and if the file is not there, it will return null or 0. Okay, null is a symbolic constant that normally stands for 0, and this name is again coming from the header file. Okay, so this is otherwise, suppose if the file is there and I am able to successfully open it, then there will be a structure variable created corresponding to the file, or representing that file, and the address of that structure variable will be returned by this function. Okay, so fopen essentially what it does, it opens a file, and in whichever mode we are specifying, and the address of, so whatever address it is returned, we can roughly say that it is the address of the file. Okay, or it represents the file, opened file. The address returned by this will represent the opened file. Okay, now after fopen we have fclose also. Just I will demonstrate a program today before winding up, so that you are excited about it, or you get some interest about this. So I am deleting some files here. Okay, all the files here I will delete, text files, and I have some other files, program files here. So in my program, what I am going to do is I am going to create a file, or I am trying to open a file which is not existing, and I am opening it in write mode. So there is no file existing here with the name input.txt. No file existing here, if you can see. Now after I execute this, it's asking me to enter a character. I'm entering a character, say Y. Now if I go to my hard disk or in my files, there is a file called input.txt. I open it, I can see W written there. Okay, what happened is my program created a file called input.txt, and the character entered is taken from the user using the function getChar, which we studied, and we are writing into the file. Okay, so we using the program we created a file, notepad file or a text file, and I wrote one character into that. More about this we will discuss in the next class. If any doubt is there, you can ask, or we will meet in the next class. Okay, thank you.